All right, in this module, we are going to talk about compound light microscopes. And we're going to start with a quiz question that's going to be on the quiz for this week. And I want you to think about what properties and or structures will optical microscopy allow you to characterize. So this class is about characterization. What can optical microscopy give us? See if you can come up with properties and structures. So fill out the quiz question and we'll come back and discuss compound light microscopes. All right, let's look at compound light microscopes. So a compound light microscope produces a magnified image of whatever object we're looking at, and it projects it onto the retina in our eye, but it can also do that projecting of an image to a photosensitive surface and display it on a computer screen. So we have options there. So let's sort of go over the instrumentation of a compound light microscope, and this should help us sort of understand what we have. So I've put an image of a compound light microscope. So this is the type of microscope you're going to see if you go into a lab and you have a light microscope. So this kind of shows us all the different components on the outside, but also on the inside. So first of all, we have the eyepiece. This is where you're actually going to, stick your face in front of it and look at the image. We sometimes call this the ocular, as you can kind of see over here in the labeling, but that just means we're looking at an eyepiece. Next, we have an objective lens. In this case, we have a turret of multiple objective lenses. These are what's producing a magnified image, so they're very important to the microscope. We also have a stage. So this large rectangular black piece is the stage which holds our specimen or sample, and it allows us to also move it around instead of moving everything else around. We also have a condenser, in this case below the stage. This focuses the light that is being produced, and the light is being produced by the lamp. So in this case, it's called a lamp house. There's various components of that, but more or less everything here on the back is what we would refer to as the lamp, which actually produces whatever form of light that we're having. So as you can kind of see from the interior here, this is a mercury arc lamp in this case, but that's what's producing the light. Lastly, things we'll talk about is the focusing knobs. It's a little hard to see on this exterior drawing. This is typically what moves the stage, but below it, the circle is the focusing knob. So you can see it over here on the drawing on the right. This allows us to move the specimen in and out of focus. And what it does, how it does that is by moving this mechanical stage up and down so that we're in the right optical plane. So that's kind of an overview of some of the various components that we have in this compound light microscope. And if you're still wondering what the compound part of it means, it's simply the fact that we have multiple lenses. So in this case, two. We have the objective, which magnifies the image, and we have the eyepiece, which produces the image for the eye. And so the combination of those two is what gives it the compound name. So ocular or eyepiece plus the objective, and that's what gives us the compound part of compound light microscope. All right. This is, like I said, a compound light microscope, and the image is obviously magnified. That's what we're trying to get. We're trying to get a larger view of something that's on the microscale. And so when we look at the magnification, and I'm going to call the magnification, as I write it out here, and I'm going to symbolize that with a capital M. So the magnification of this compound light microscope is going to be M final. Because it's compound, it's going to be the product of both the magnification of the objective lens, which I'm going to abbreviate with OBJ for objective. And then it's going to be multiplied by the magnification of the ocular OC, also the eyepiece. So because it's a compound light microscope, the overall or total or final magnification is the product of the objective magnification, M sub OBJ, times the magnification of the ocular or eyepiece, OC. And that's, again, coming from the fact that this is a compound light microscope. All right, so we're back here looking at an image or images of compound light microscopes, and I want to sort of just conclude this module by talking about the things that are kind of most critical. If we have to pick a couple, what are the most critical components for forming an image? And the two that we're going to focus on, and as we go through light microscopy, we're going to spend the most time on, one is going to be the objective. These are the lenses. They collect light that's diffracted by the specimen, and it's what actually forms that magnified image, and it's going to be a real image, and we'll talk about that here in a second. But it does that, and it does it near the eyepiece. So we're producing a magnified image. Secondly, the second critical component is going to be the condenser. This is what focuses the light that we get from the lamp or the illumination system onto a small area of the specimen that's situated at our stage. And so the condenser is kind of the focal point of the light system that produces it on a uniform small area. And so that's very important, and we're going to talk a lot about the light system and how that works, but also the objective, which is what's forming the magnification, which is what we're after with a microscope.